Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this section, we are going to finally discuss deep Q-learning. What you should find interesting is that aside from a few miscellaneous modifications, most of this stuff you have already seen before. I've set you up so that you already know all the different components that are going to go into this. Specifically, deep Q-learning can be used for playing much more complex games, like Atari video games, using techniques you already know, plus a few minor modifications. But first, let's discuss some practical issues. One thing to note is that actually training your agent is going to take a very long time. Why might this be? Well, first consider the size of the input or state space. Cartpole has 4 inputs and Mountain Car has 2 inputs. If you look at the state space of the Atari game Breakout, I see that it's a box of 210 by 160 by 3. Let's say we can get rid of the 3 to turn our screen into a black and white image. So now it's just 210 by 160. Now if you're familiar with typical screen resolutions, you know intuitively that 210 by 160 is a very modestly sized screen. So this is already way smaller than a typical video game. But at the same time, 210 times 160 is 33,600. So we're going from 4 inputs to 30,000 inputs into a neural network. This is going to take much longer to train, since the patterns that have to be learned are much more complex. So be ready to spend multiple weeks on just one agent for one game if you're using your CPU. Some models on even a GPU will take a week or more to train. Let's do a quick calculation. Suppose you're using a P2X large on EC2, which costs 90 cents an hour. How many hours are there in a week? That's 24 times 7, which is 168 hours. Multiply that by 90 cents. That's over $150, and that's just one training instance. I usually like to test out different hyperparameters as well. So say you wanted to test out 10 different settings of hyperparameters. Now that's $1,500. Needless to say, this is impractical for most students of this course. So how do we resolve this issue? Well, we are not going to let this stop us from writing code. So first and foremost, we are still going to discuss the concepts and put them into code as usual. In that respect, the course is going to proceed as normal. At the same time, testing this code yourself may be impractical. My recommendation would be to not spend hundreds of dollars on a GPU, but rather just run the code on your CPU and look for a little bit of improvement. This is good enough, since understanding the concepts and putting them into code is the important part. Realistically, if you were ever in a situation where you needed to apply these techniques, say at your job, then you would be given the resources to do so. In other words, if your company is asking you to build a reinforcement learning agent that uses a big deep Q network, then they'll be the ones paying for it. So all the more reason to get good at this so that you can apply for jobs in deep learning and succeed.